Okay, let's go on the experiment on lenses. Today we are dealing with lenses. Let's try to find the image, right, of an object using a lens. So today we have three objects in today's experiment. We have two parts, part A and part B. In part A we have only one lens, and in part B we have two lenses, a combo. Okay, great. Now let's see. This is a question of the lenses, right? This is equals to 1 over DO plus 1 over DI equals to the focal length, right? DO is the distance from the object to the lens, right? DI is the distance from the lens to the screen or the image, right? Okay, now in the focal length is the distance where a faraway object, right, is on the screen and is the best image. For example, imagine that we have a faraway object. We have on the screen, we have a magnifying glass. Today we are using magnifying glasses, right? This is a homemade experiment, right? So we have a faraway object and we're looking for the image, right? The image, where the position where we get the best image, right? And the distance, the position of the screen to the distance to the lens, right? That is called the focal length, right? Okay, it's found for these two lenses. We have the first one, the focal length is 15. This is for part A. For part B, we're dealing with another one, which focal length is 19 centimeters. Both are in centimeters. Okay, let's do it. Let's do in this experiment five cases, right? Case one, when the distance from the lens to the object is more than two focal lengths. In the focal length right here is 15, right? Twice is 30. So let's go to 40, right? So case one is when DO, the distance from the object to the lens, is 40 centimeters. The focal length is going to be again 15 centimeters. Okay, now using the equation, the lens equation, and solve for DI from the theory, this is from the theory. So DI is going to be 1 over focal length minus 1 over DO, right? Inverse, right? Now let's just plug the values right in the equation, show the values on this equation and the answer. From the experiment is found to be 23, and I'll show you later how we did it. But it's found to be around 23 centimeters. Okay, taking this into account, let's find the percent error. You know how to do it. It's gonna be DI from the theory minus DI from the experiment divided by DI from the theory times 100%. Okay, perfect. Now let's go for part two, case two, right? Now DO is twice the focal length. The focal length is 15, so twice gonna be 30 centimeters. Let's place the lens at 30 centimeters from the object. The object in this case is this light, this lamp. That's the object, right? So the distance between these two, right, for case two is gonna be, right, 30 centimeters. Okay, great. Now let's use the equation, right? This equation is the same for all of them, right? For DI, to find DI. Okay, it's gonna be DI theoretical, again 1 over focal length minus 1 over DO. DO again is gonna be 30 in this case, inverse. Okay, let's show values and find the answer. Okay, from the experiment is found to be 29 centimeters. I'm gonna show you again how I did it before. Okay, and one more time, let's show the equation and the values for percent error. Perfect. Now let's go to case three. Now case three, DO, the distance from the object and the lens, is in between 1 focal length and 2 focal length. Right? Let's say, just picking the value, let's say 25. Let's do 25. So DO is 25. Now let's find the theoretical value using the same equation, right? And the experimental value is found to be 37 centimeters. Okay, again, let's find the percent error for these values. Great, now let's go to Case 4. In case 4, let's place the object at one focal length from the lens. Okay, this is the lens, right? And again, let's calculate the distance of the image, right? The distance from the image from the lens to the screen. Okay, which is the eye. Perfect. Now, it's found in this experiment that no image is on the screen. This is the screen for today's experiment. No image is found on the screen. Okay. When the image is not found on the screen, we have two special cases, or two cases. One is that the image is virtual, right? If the image is real, right, we can place the image on the screen. If the image is not real, in this case it's virtual, right, we cannot see it on the screen, right? Now, this is one case, this is one possibility. Another possibility is that we cannot see the image on the screen if the image is very, very, very far away, right? And that answer is found on the formula, using the formula. The formula is telling us which type of image is this one when we cannot see on the screen. Again, two cases. If you cannot see it, it's because the image is virtual. If the image is virtual, the sign of the eye is negative, right? The eye from the theory. If the eye is negative, when we do the calculations, right, means that the image is virtual, and that's why we cannot see it on the screen. Now, if the eye from the theory is a big number, right, means that the image is very, very far away, also we cannot see it, right? And that could be one of these two cases, right? When that happens, because we have two cases, right? Case 4 and case 5, we don't see the image, so don't worry about to calculate the percentile, right? Because we don't have the experimental value. Okay, now let me show you how we found these numbers. Okay, so we have in this case the object is represented by this lamp. We have this lens, right? That's just a magnifying glass, right? Lens. And now we have the screen. Where is the screen? Perfect. Here you can see the image, right there. There's no image. We're supposed to see, right, the image of the filament of this lamp, right? The filament image looks like an end like this. Right, let's try to get the best image on this screen, and when we get it, we get then the distance, the eye from the experiment. Okay, let's do it. Let's start with case 1. Case 1 DO is 40 centimeters. Okay, so let's make 40 centimeters from the lamp to the lens, correct? Okay, now I'm looking for the mirror. Where's the mirror? Right here. Oh, I found it. Okay, now let's measure the distance, right? More or less 40 centimeters. Okay, a little bit more. Okay, a little bit more. Farther. Okay, this is again about 40 centimeters. Great. Now we get DO. Now let's find the eye. Okay, to do that, let's use the screen, right? And let's play moving back and forth, right? Maybe you can see from there, right? Back and forth until you get the best image of the filament, which is that one, right? And it's found to be more or less, right? Well, it must be dark to make it better calculation, but if it's dark, you cannot see it, okay? Okay, imagine this is the case. So the best image right there. Now let's calculate again the distance, and the distance is 23 centimeters for case 1. Okay, now let's go to case 2. The distance DO from the object to the lens is 30 centimeters. Okay, let's move back, right, this lens, right, and let's try to find the new distance, right, which is 30 centimeters, a little bit more. Okay, about 30 centimeters. Perfect. Now let's play with the screen moving back and forth the screen to get the best image possible. Okay, and one more time, we move back and forth, right. Maybe you can see from there, let me do it this way to get that in there, right. And it goes like around here. Let me see. Okay, maybe around there. Okay, perfect. Got it. Now, one more time, let's measure that distance from the screen to the lens, right, which is the eye. And the eye is found to be, right, 29 centimeters. Got it? Okay. Now let's go to case 3. For case 3, DO is gonna be 25 centimeters, right? Let's do it. Let's close this, the object and the lens, right? And let's make about, right, 25 centimeters. Imagine this is the case a little bit further, right? 25 centimeters, more or less 25 centimeters. Okay, great. Now let's try to find the best image on the screen. One more time, right? Move the screen back and forth, right? And we get more or less, right, the best image of the object, right? Okay, now let's measure that distance, and the distance is about, according to this, right, 37 centimeters, right? 37 centimeters is the best picture that's possible, right, to get using these devices. Great. Okay, now let's go to case 4. In case 4, right, DO is 15 centimeters, which is the same look as the focal length, right? Let's see what happens when the distance DO is the same as the focal length. Okay, let's do it. It's gonna be 15 centimeters. Okay, let's get closer to this one a little bit more. Okay, 15 centimeters. Okay, great. Okay, that's about 15 centimeters. Perfect. Now let's find the image. Okay, let's move back and forth, right? The screen, so no image, right? And no image is on the screen, right? When that happens, when we cannot see an image, we have two cases, right? The image is virtual. If the image is virtual, so the eye is negative, according to the theory, right? The other case is if we cannot see on the screen the image, it's because the image is very, very far away. Got it? Okay, perfect. Now let's go to the last case. The last case is when DO is 10 centimeters. Okay, so let's go to 10 centimeters, more or less. Right, this is 10 centimeters. Okay, now let's do the same thing. Let's find the image, right? As before, as you can see, no image is found. Please, from the theory, specify for the last two cases, specify why we cannot see the image on the screen. I just mentioned, right, that we have two cases. Now specify why for case 4, why is not on the screen. The same thing for case 5, correct? And of course, for the last two cases, right, the last two cases, we don't have person error because the theoretical or from the experiment, right, we cannot get right the image on the screen, so we don't know the distance, right, from the experiment. Okay, now let's go to part 2 or part B, right? In this case, we have a combo, 2 lenses, right? We have an extra lens from case 1 or part A, right? And the second lens is 19 centimeters. Now, let's make a combo and let's try to find an image produced by the combo. Okay, let's do it. So we have, in this case, another lens, right? Perfect. Now let's try to create a image using the combo, right, of these 2 lenses. Okay, great. Look, let's play with these 2. Let's play, right, to make a combo. Let's play also with the image, moving the image back and forth, right? put it this way, maybe it's better. Must be in darker condition, right? But let's see if we can do it without darkness, right? Let's see. Okay. Oh my God. Sometimes it's not easy to find it. Okay, right away, how to play button 4. Okay. Wow, like this one. Can you see it? It's a very small image. Okay. Maybe I can play like this to increase the image like this. Oh my goodness. It's too small in this case. Okay, let's play. Okay, looks like, oh my God, I cannot see it because it's so small. Okay, let me take another situation, maybe right here. Let's see what happens. And play with the image. Wow. One more time. Now let's approach these two. They're supposed to be aligned. Let me see if they're aligned. Because they're not aligned, of course, we cannot have this the right image. Okay, imagine they're aligned. Okay, one more time. Let's look for the image. Oh my God, it's too small. Okay, let's try this one. Okay, let me see if I move a little bit more this one. Okay, better. Okay, much better. Maybe I need my glasses. Okay, my glasses. Okay, let me see. Wow, no wonder I need my glasses. Okay, great. Okay, I found it. Look, I found the best image. You cannot see, but I can see it. I can do it for you. Okay. Now, let's see the distances. Where is the? Sorry, the meters right here. Let's find DO. Right, DO is gonna be, for this case, right, let me try to do it very carefully. Okay, oops, it's gonna be about 28. Let me double check. 28, yeah, 28. So from the experiment, right, DO1, look in the figure. DO1 is this one right here, right? DO1, this distance, DO1, we said it's equals to what? 18, right? Let me double check. Okay, 18 centimeters, right? 18 centimeters. That's DO1. Okay. Now let's find the distance between the two lenses. Okay. That distance between these two lenses is about, oh my God, 14. Okay, 14. This distance from here to here is 14. Okay, 14 centimeters. I just call it D, right? 14 centimeters. Perfect. Now let's find DI2, right, from the experiment. Remember, when we have DI1, DI2, or DO1, DO2, because of this, because we have two lenses, right? The distance from the object to the first lens is DO1, right? And the distance, let's say, from the second lens, right, to the object is gonna be DO2, right? And of course, this produces an image. The image produced by the first lens is gonna be DI1, and the image produced by the second one is gonna be DI2, right? So we're looking for DI2 from the experiment because we can see it, right? DI1 we cannot see it yet. We can find it, but let's do it this way. Now gonna be DI2. DI2 is about, oh my God, 10 centimeters. 10 centimeters. So DI2 is 10 centimeters. This is from the experiment. Okay, I found when the experiment is 10 centimeters. Also, this right here, D, again, is 14, right, centimeters. From this information, okay, let's find di2 from the experiment, right? Using the equation, the same equation, right? Same equation as before, right? The length equation to find the theoretical value. So this is the condition, this is what is given. Now let's double check it using the theory and see if, right, if di from the theory is the same as di from the experiment, which is 10 centimeters. Okay, this is for part B. We can do it with calculations, right? We expect an error right around 10%. If it's less than 10%, right, should be good. Why we expect 10? Because, well, these lenses are just no very accurate lenses, right? I just bought it right on the store right last week to do this experiment at home. Okay, so hopefully this is gonna work. It's gonna help, right, to understand lenses when we have only one lens. We're looking for the image, right, using the equation, and also when we have a combo, right, a combo of two lenses. And the same thing, let's look for any quantity we can look for the eye and so on, as long as we have the rest. In this case, right, let's look for the di2, right, the distance from the second lens to the image produced by this combo, right? And let's double check this from the theory, and also at the end let's find the percent error, right? The percent error. Okay, great. See you in the next experiment.